Hi. So for part C of this question, we're told that the particle is now held on the same rough plane by a horizontal force of magnitude x newtons. And I've drawn it in, extending from the particle into the slope. Okay, so I've taken the force and I've just shifted it along there. So I have all my forces coming from the particle outwards rather than into the particle to keep consistency. The particle is in equilibrium and is on the point of moving up the plane. Okay, find the value of x. Okay, so we can start to resolve. I know that this angle is 30, and I know that the weight and x are perpendicular, therefore this angle is 60. Okay, so what I can do now is start to resolve all of my forces. So I'm going to resolve my weight into and down the slope. Okay, so the force that includes the angle is cos, so this force is 0.8 g cos 30 newtons, and the angle that does not include, and the forces that does not include my angle is sine, so this is 0.8 g. This force is 0.8 g sine 30 newtons. I've got my normal reaction coming there, and I can resolve now x. Okay, so I can resolve into the slope. Again, the force that includes the angle is cos, so this force is x. Cos 60 newtons. And the force that does not include the angle is sine. So this force is x. Sine 60 newtons. Okay, and I've got my reaction here. And the particle is on the point of moving up the plane. So the particle is just about to move up the plane. And we know that friction always opposes that motion, or that attempted motion. So friction is acting opposite. So friction is acting down the plane. Okay, and I know that the friction equals mu r from the previous question. Okay, that's going down the plane. Okay, so now we can start to resolve. Okay, so first of all, I'm going to resolve into the plane. So I have 0.8 g cos 30 plus x cos 60 minus r equals 0. No acceleration happening here. Acceleration is 0. So if I rearrange for r, we can therefore say r is equal to, and what I'm going to do now is I'm going to minus 0.8 g cos 30, and I'm going to plus r on both sides. I can just plus r on both sides. That'll be much easier. Okay, so I get r equals 0.8 g cos 30 plus x cos 60. Okay. What I can do now is resolve up the plane. Okay, so like in the previous question, it's always advisable, doesn't have to be a must, but I like to always resolve in the direction of the movement or of the attempted moving. So the particle is just about to move up the plane, so I just decided I'm going to resolve that direction as well. Okay, so up the plane we have x sine 60 minus 0.8 g sine 30 minus the friction force. Okay, we know that friction force is mu r. Okay, and again, no movement happening as of yet, just on the point of moving, so at the moment the acceleration is 0. Okay, so what I'm going to do now is we can substitute r into this equation. So we have x sine 60 minus 0.8 g sine 30 minus mu times by 0.8 g cos 30 plus x cos 60 equals 0, okay? And if I expand these brackets, x sine 60 minus 0.8g sine 30 minus 0.8 g mu cos 30 minus x mu cos 60 is equal to 0, okay? So what I'm going to do now is I'm going to solve for x. Okay, so if you notice, I'm left with one equation. The only thing I do not know in this equation is x. Okay, sine 60 and sine 30 and cos 30 and cos 60 can all be calculated. G is 9.8. Mu we know from the previous question to be 0.507. I can plot that here. And we want to find x. Okay, so I'm going to plus 0.8g sine 30 plus 0.8g mu cos 30 on both sides. Okay, so I'm just left with all the terms containing the x. I can therefore say x sine 60 minus x mu cos 60 is equal to 0.8 g sine 30, because we plus that on both sides, plus 0.8 g mu cos 30. Okay, now what I can do is factorize out x because it is common. Sine 60 minus mu cos 60 equals 0.8 g sine 30 plus 0.8 g mu cos 30. Now dividing both sides by the bracket. Okay, we can therefore say x is equal to the right hand side, which is 0.8 g sine 30 plus 0.8 g mu cos 30 divided by that bracket, which is sine 60 minus mu cos 60. Okay, so when we plop that into our calculator, we should get a value of x to be 12.0 newtons to 3 significant figures. Okay, so I hope you followed, and thank you very much for listening. We'll pick up again in the next video for question 5.